Alright, we had this problem set up, the disk with uniform surface charge density sigma and total charge q. Sigma is q over pi r squared, the surface area. We want to find the electric field of this disk at this point P, which is at, on the axis of the disk and distance z above the center. And we want to use the electric field of the ring we calculated before, which is kq of the ring times the z, distance above the ring, divided by r squared plus z squared to the 3/2. So in order to use that, we divided this area into many rings like that, with each one radius r and the thickness or width of dr. And we say that this has charge dq and creates an electric field vertically as dE, and then E total will be integral of dE. dE is that of the ring, which is this one with the appropriate parameters, integral of k dq and z divided by r squared plus z squared to the 3/2. And then what is dq? Because this has charge dq and area dA, sigma is dq divided by dA, and dq therefore is sigma dA. And then dA, we said, is equal to, if you break this and open it up, the one side is the circumference of this circle, the other side is dr. So it's 2 pi r dr. Therefore, dq is 2 pi sigma r dr. So we put that in here and integrate over r, then E becomes integral k times dq, which is 2 pi sigma r dr times z divided by r squared plus z squared to the 3/2. And all the constants can come out. R, which is the variable, goes from 0 to the radius of the disk. From here, we add the contribution of all of these. And all the constant comes out. And let's say E equals to 2 pi k sigma z integral r dr divided by r squared plus z squared to the 3/2. And then because this is U substitution works here, we can take r squared plus z squared equal to U. Then 2r dr becomes du, and this 2r dr becomes du, then E becomes pi k sigma z integral u to the negative 3/2 du. So integral of this becomes u to the power negative 1/2 divided by negative 1/2. So E becomes negative 2 pi k sigma z and times u, let me put back u, square root of u, 1 over square root of r squared plus z squared, and then evaluated between 0 and r. 0 and r. So E will be negative 2 pi k sigma z. If I put z in here, let me put z inside, evaluate for r, so it will be z divided by r squared plus z squared under square root minus, if you put 0 for r, then it becomes 1 over square root of z squared, which is z minus 1. Then you can apply this negative sign. E becomes, instead of 2 pi k, also I write sigma over 2 epsilon naught. This is 1 over 2 epsilon naught. And 1 minus z over square root of r squared plus z squared. And if you look at this, situation, if you put this, if this is a right triangle, if this angle is theta, z divided by square root of r squared plus z squared, which is this r, z over r becomes cosine theta. So this will be E equal to sigma over 2 epsilon naught times 1 minus cosine of this theta. Means you can put sigma over 2 epsilon naught times 1 minus the cosine of this angle. If you will stand at point P, at what angle do you see the edge of the circle to the center? And that would be theta in cosine theta. If r is very, very large, theta is 90 degrees, you see the edge at 90-degree angle. If you are in an infinite plane, then cosine of that is 0, and then get for infinite plane, you get sigma over 2 epsilon naught, as we expect. And if theta is very small, means that if you shrink this to a point, then you can use the Taylor series for cosine and get a new result. If theta is much less than 1 radian, you can use cosine theta as Taylor series of cosine is 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial and so forth. But if theta is very small, you can ignore this, and then E becomes 1 minus cosine theta, so 1 minus sigma over 2 epsilon naught times 1 minus theta squared over 2. If you ignore the higher order term, 1 minus 1 goes away, this negative times negative becomes positive, we get 4 in the denominator, get E equal to sigma over 4 epsilon naught theta squared. So what is theta? If theta is very small, you can write theta as in radian as the r over z. So if theta equals to r over z. If r is much less than z, theta is just that, like that in radians. So E becomes sigma over 4 epsilon naught r squared over z squared. But sigma is total charge over the area pi r squared. So Q over pi r squared times the rest of it, r squared over 4 epsilon naught times z squared. You see r squared cancels, and then E becomes Q over 4 pi epsilon naught z squared. Which is the electric field of a point charge at distance z. So if this shrink this to a point at distance z, it has an electric field of the point charge as expected. Or you write it in terms of k becomes kq over z squared.